In this video, we are going to take a look at reducing the expression -3 cos squared x plus sine x minus 7 divided by 27 sine cubed x minus 125. So as we've been talking about in the previous examples, in order to reduce, we want to find something that will divide into both the top and the bottom. And in order to figure out what divides in, we first need to figure out what multiplies to give me those expressions, which is basically factoring. So I need to start by factoring the numerator, factoring the denominator, and then trying to see if we can reduce. So I prefer to factor off to the side. However, if you'd like to just do it in the main expression, that is fine. I'm going to take the -3 cos squared x plus sine x, take away 7, off to the side, and see if we can factor. Now looking at this, it has 3 terms. I notice that it does not currently have a common factor, and it is a trinomial. It has 3 terms, but the terms are currently not the same trig ratio, which means I can't factor. So what I'm going to need to do is either find a way to write the cos squared x using sine, write the sine x using cos, or write both of them using something completely different. So in order to do that, I am going to look at my identity sheet. We are working with the 8 identities kind of in the middle, the reciprocals, the quotients, and the Pythagorean identities. What I want to do is see if I can find an identity that has both sine and cosine in the same one. So if I look at the reciprocals, I don't see any that have sine and cosine in them. Looking at the quotients, I do have tan x, which has sine and cos in it, and cotan x, which has cos and sine in it. So I could use one of those. And then looking at my Pythagoreans, I do have the very first one that says sine squared plus cos squared equals 1. And that's the one that I'm most drawn to because it has a cos squared x in it, and we have a cos squared x here. If I try to use this one, I'm going to be introducing tan or cotan, which is just another ratio for us to worry about. So I would prefer to try to keep it just sine and cos if I can. So I'm going to try the sine squared plus cos squared equals 1 and see what I can do with that. So off to the side here, I'm just going to write sine squared plus cos squared. I'm not saying the x, sorry. Sine squared x plus cos squared x equals 1. Now I can rearrange to get the cos squared x by itself if I subtract sine x from both sides. So I would get cosine squared x equals 1 take away sine squared x. And then what I'm going to do is take out cosine squared x and put in 1 minus sine squared x. All right, if I do that, this is going to give me -3, and then cos squared x is going to become 1 minus sine squared x. Since it's 2 terms, we should put it in a bracket, and it is being multiplied by the -3, so we definitely need a bracket. And then I still have the plus sine x and the take away 7. Okay, I do see that at least everything is in terms of sine. I do need to do a little work on this before I can factor it. So I am going to distribute the -3 into the bracket. That's going to give me -3 and then plus 3 sine squared x plus sine x and then minus 7. I do have some like terms. I've got the -3 and the -7. So I'm going to have 3 sine squared x plus sine x. And then -3 take away 7 is -10. So that was an awful lot of work, and we still haven't factored. All we've done is get it into a form where we can factor. So from here, it's up to you. If you would like to use variable replacement, you can do that. If you would like to just factor it using the signs, you absolutely can do that too. I am tempted to do the variable replacement. If I do that, I would take out the sine x and maybe use an a instead. So if I do that, this is going to become 3a squared plus a minus 10. So this does have three terms. They do not have anything in common. So I can use decomposition. I would look for two numbers that multiply to the first and last. That is negative 30. And then add to the middle, which is a secret 1. So things that make 30 would be 1 and 30. Those do not add or subtract to a 1. 2 and 15. I could make a 13 or a 17. 3 and 10, I could make a 13 or a 7. 4 does not divide evenly into 30. 5 does, 5 and 6. I could make a 1 out of a 5 and a 6 if I do positive 6 and then take away 5. So I'm going to replace that middle term of 1x with the two terms, negative 5x and then plus 6x. I think the 6 goes better with the 3, so I'm going to put that first, and then the 5 after it. So I have 3a squared plus 5a minus 5a plus 10. I'm going to group first two and last two. First pair, both divide by 3, both have an a. 3a squared divided by 3a is just 1a. And then 6a divided by 3a is 2. I always take the sign that is in between the pairs. 5a and 10 both divide by 5. So negative 5a divided by negative 5 is positive a. Negative 10 divided by negative 5 is positive 2. I notice at the step that these two brackets are the same, which they should be. So I get a plus 2. And then 3a minus 5. Okay, a lot of work just to factor one expression here. This is going to end up being, if I put the sign back in, sine x plus 2. And then 3 sine x minus 5. And I'm going to put that back in to our original expression. Now, I'm concerned that I have not left myself enough space, so I'm going to come as close to the edge of the margin as I can in order to write this all down. Sines and cosines take up a lot of extra room. So I have sine x plus 2 and 3 sine x minus 5. Okay, in the denominator, I have a 27 sine cubed x minus 125. Okay, I have a choice. I can either take out the sine x and put in an a and factor that off to the side, or I could just try to do it as is. So if you want to do it as is, that's fantastic. I think I'm going to try the variable replacement off to the side. So I'm going to take this. Same thing, I'm going to put a in for sine x again. All right, and if I do that, I get 27 a cubed minus 125. Okay, if I consult the factoring flowchart, this has two terms. It does not have a common factor. 27 and 125 only have a 1 that divides into both of them the same, so unfortunately no common factor. If I keep looking at it, it's not a difference of squares. It does have two terms, they are being subtracted, but 27, 125, and a power of 3 are not perfect squares, but it is a difference of cubes, right? It has two terms being subtracted. 27 is 3 to the power of 3. 125 is 5 to the power of 3. And the a obviously is also to the power of 3. So this is something that I can factor as a difference of cubes. Now, if you would like to write in the step where you write them all as powers of 3, we can do that first. It is not mandatory. It's up to you, whatever makes most sense to you. So 27 is 3 to the power of 3. You can find that on your power sheet. So that means we're going to have 3 to the 3 and a to the 3. So I can say this is really 3a and then to the power of 3. And then we are taking away 125, which is also 5 to the power of 3. You can find that on your power sheet. Okay, when we are doing a difference of cubes, we start by cube rooting the first term. So the cube root of 3a cubed is just the 3a. And then we cube root our 5 to the power of 3, which is just 5. And we keep the sign that is in between them. And then in order to get that second bracket, the order that I like to do, I like to square the first one. So I'm going to square 3a. So 3 squared is 9. A squared is a squared. Okay. I like to square the last term. So I'm going to take -5. If I square that, I get positive 25. You'll notice I wrote that at the end. And then to get my middle term, I multiply these two together. So 3a times 5 is 15a. Now it would be negative, but in order for all of those middle terms to cancel out, the sign that goes here has to be the opposite of the sign that is here. So this is a minus, this one here has to be a plus. So that is always a plus because anytime you square a number, always positive. And this has to be the opposite of what I see in the first bracket. Okay, this second bracket does not factor. It never will unless there is a higher exponent. So if it was to the power of 6, it might factor again. But if it's just a power of 3 in the original question, that second bracket will not factor unless there was a common factor that you missed in the original question. Okay, so I'm going to take this. Everywhere we see an A, we're putting back in the sign. I'm just going to write that over here. So this is 3 sine x minus 5 times 9 sine squared x plus 15 sine x plus 25. Sorry, I had to try to write as small as I could to get that all to fit. Okay, now it's hard to remember what it is we were even doing in this question because we spent so much time factoring that expression, but we are trying to reduce. So I am looking for something on the top and the bottom that I could divide out. So I do see that I have a bracket that matches the 3 sine x minus 5. So I'm going to say that this is the same as sine x plus 2 and then times 3 sine x minus 5. Left some space because I know the denominator of the next part is going to take up a little too much room. And move that times sign down. All right, and then this is 3 sine x minus 5. I'm going to write that at the end. And then times 9 sine squared x plus 15 sine x plus 25. Now, the 3 sine x minus 5 divided by 3 sine x minus 5 is really just a 1. And then anything times 1 is itself. So this ends up just being sine x plus 2 over 9 sine squared x plus 15 sine x plus 25. Phew, that was a lot of work. All right, and then that is my final answer. There is nothing else that we can divide out, right? You cannot cancel things that are being added or subtracted. We can only cancel things out when we have multiplication. Okay, I believe we have one more question to go on the next side of the page, so I will see you in the next video to do that question.